Hello, I'm Don Leafy with Gulfstream. It pleases me to welcome all of you to Wring It Out Volume 2. Even more advanced aerobatics. We're filming today at a new facility. We're about 15 miles outside of Athens, Georgia at Taylor Jenkins Airstrip. Taylor is quite an interesting fellow. Besides being a full-scale pilot, he's quite an accomplished modeler. Taylor, thank you for allowing us to come out here and use your facility. These planes are gorgeous. You mind telling us a little bit about them?
Okay, the P-38 here is kitted by CBA Models up in Warren, Ohio. I did the fiberglass molds for them, built them some dozen or so booms that go with the kits. It has a 10-foot wingspan, retractable landing gear. It will take two 4.2 Sachs engines and some 6 to 8 servos to operate it.
It's gorgeous. It is gorgeous.
Thank you.
What about this P-26?
The P-26 has always been one of my favorites. This is a quarter scale model here, 84-inch wingspan. I'm working on a third scale model now that I plan to kit myself. Should have it out in about a year.
Well, we'll all be looking forward to that. Taylor, once again, thank you so much for allowing us to be out here. I think everybody would like us to go on and get to the part where David comes on and teaches us more.
Hi, Don. It's good to be back. From the first videotape, we talked about the basic building blocks of maneuvers. We learned that the most sophisticated maneuver was essentially built up from the basic loop, roll, snap, or spin. In this video, we're going to talk about more precise flying, taking these basic loop and rolls and learning to put them where they need to be, how to practice, etc. We'll also learn that a well-disciplined precision flyer will be better able to tackle the more advanced hot dog flying, which we'll talk about in video number 3. Don, before we get into the nitty-gritty, we're going to assume that we have a good aerobatic airplane, such as an extra, ultimate, good pattern ship, such as the Conquest, an airplane capable of doing the aerobatics that you want to end up doing. Also that you have it adjusted vis-a-vis the throws, the gap sealing engine, etc., such as what we talked about in the first tape. With that in mind, then we can move on and start doing the more advanced aerobatics.
Good, let's get started. David, I've noticed some planes with a tune pipe and some without. Is there an advantage to having a tune pipe?
Yes, there is. The main two advantages are, first, you get more power, and it's a quieter setup as well, generally quieter than a conventional muffler. To do aerobatics, you don't need the extra power, but it's nice, particularly in vertical maneuvers. As for setup, we'll talk about quickly on how, if you don't have any numbers from the engine manufacturer or you're starting from scratch, start with a full header, full length, run the engine, and tack it carefully. Cut off maybe 1/4 inch of the header, tack it again. If you notice an increase of RPM, keep on knocking off 1/4 inch off the header until you stop noticing a gain of RPM. Stop there. That's probably pretty close to being right. As for the YS long stroke, which we're using here, and the Hattori 650 pipe, which is a very popular pipe in the pattern circles, we like to use a 7-inch header, or it's about 14 inches from the glow plug to this screw. And if you're not using a Hattori pipe, use about 16 inches from the glow plug to the high point, or where the bend stops right here. This is a good starting point on the setup. Bear in mind we're using a 1211 or a 1212 prop and about 20% nitro fuel. This setup works very nicely.
David, in Wring It Out Volume 1, you went over tuning up 2-stroke engines. I'm noticing a lot of 4-strokes being used. Can you give us some tips about that?
Sure. The 4-stroke engine does take a little different technique. The modern 4-stroke is really a terrific engine. Lots of power, smooth running, and becoming quite the choice on aerobatic flyers. The 4-stroke requires, in general, a much richer setting than what we're used to with a 2-stroke. In fact, what we talked about is pinching the line and noticing what happens to the RPM on a 2-stroke. That's not what we want to do on the 4-stroke. What we want to do is set it up quite rich, slowly lean it out to notice maximum power or near it, and maybe richen it up a bit. Unlike a 2-stroke, a 4-stroke will deliver 95% of its power at a very rich setting. As for fuel, it's pretty important to use a good quality fuel. 4-stroke is a busy engine, has a lot of parts. There's some debate on two-stroke and four-stroke fuel. I would recommend using a two-stroke fuel in a four-stroke, primarily because it has additional oil. One of the things that more recently we're doing is we're adding nitro to get more power to the four-stroke. While it's not necessary, these engines will run very nice on 10% fuel. Some people have gone as far as running 40% and 50% nitro and getting tremendous amount of power, and they seem to be holding up quite nicely. When you're running a 10% fuel, as for a prop, you'll probably want to run around a 14-10. 20% nitro, you probably want to go to a 14.5, 12 or so. 50% nitro or 40%, you probably want to go as high as 15-12 propeller. We've been running a 15-12 on 40% and turning in the order of 8,500 RPM. Generally, that's a good RPM range regardless of nitro and prop. Try to get your, for example, a YS around 8,500 to 9,500 RPM. No higher than that. It's very, very hard on the engine.
David, can you take some of the mystery out of prop selection for me? How do you tell when you're over-propped? How do you tell when you're under-propped?
Sure. Basically, it's RPM related. If you're under-propped, your engine will over-rev. If you're over-propped, it'll under-rev or be overloaded. It's like selecting the right gear in your car when you're driving. You should start off by using the prop that the engine manufacturer recommends. For example, let's say we've selected a 60 to use in a biplane, and the engine manufacturer recommends a 1211. We know that the biplane is going to have more drag and it'll require probably more thrust. So we'll probably say, well, let's go up in diameter to get more thrust. What should the pitch be? Well, you take the 12 times 11, that'll give you 132. That is what I would call a prop loading factor. You take your new diameter, which is 13 inch, divide it into the 132, that'll give you 10. So your prop now should be a 1310, and that should work quite nicely.
Okay, well, what about three-blade versus two-blade?
The three-bladed prop will offer more ground clearance and is aesthetically a neat propeller to use in certain instances. But for ultimate in performance, stick to the two-bladed prop. That's a more efficient design.
Good. Dave, it seems that soft mounts are being used more and more in this hobby. You see them everywhere. Is there a true advantage to using soft mounts?
Sure is. Three significant advantages. One is it's a quieter setup, less noise. The other is that since you're not transmitting the vibration directly to the airframe, you can build a lighter airframe, make your airplane lighter for the same amount of power. And thirdly, it's easier on the radio, since you're not transmitting the vibration directly to the radio. In the old days, it was not uncommon for us to service our radios, particularly the servos, every 100 flights or so. Now it's not uncommon to go 300 or 400 flights between having to service the servos or exchange the servos.
This mount's a two-stroke mount. What about mounting soft mounts on a four-stroke?
Right. It does take a little bit different of a setup because the tremendous amount of vibration a four-stroke has. I know that Sullivan is working on one and it's about to be released. Gator has one which some competitors are using quite successfully. I would recommend soft mounting your four-stroke if you can find a good soft mount for it.
David, with the advent of programmable and computer radios, are they necessary for good aerobatic flight?
No, they're not necessary, but it sure helps. For example, most aerobatic airplanes, or any airplane for that matter, have some coupling of controls in one form or another. In other words, if I fly along and I apply rudder, most airplanes give you more than just the rudder command. For example, if you give left rudder, most airplanes tend to roll left as well. Well, if you're trying to sustain knife edge and you apply left rudder, you don't want the airplane on its own to want to roll out. So what we do with a modern computer radio, we can mix opposite aileron, so when you apply rudder, it gives a little bit of opposite aileron to compensate for that. That gives you a truly neutral airplane, and that's easier to fly good aerobatics with that kind of setup. A couple of points to note: when you apply mix for that type of fix, only 1%, 2%, or 3% is generally enough. In other words, when you first try to add a opposite aileron mix or something like that, don't give 20%. You may end up really messing up your airplane and risking the airplane. Add only a couple of percent and build from that. Some of the features of the programmable radio are you can have exponential on one channel, variable trace ratio or VTR on another, and dual rate on a third. Like we have on our Extra 300, I have dual rate on rudder control, which we're familiar with, exponential on elevator, which softens the throw around neutral for smooth flight, yet gives me full control at the limit, and variable trace ratio, which is similar to expo, but instead of being a curved change, it's more of a straight line with a quick change up to the high point. We have that on ailerons. How we set that up is on expo, a good place to start is around 30%, 30, maybe as high as 40. Work your way up till you get the feel that you like. You know when you're wrong if it's too sensitive around neutral, and it's difficult to maintain smooth flight, or if you have to move the stick too much to get some change. That's the either extreme. And that's the same with VTR. VTR, however, takes two adjustments. You have where you want that bend to be, where it catches up, and how low that first slope is. That first slope is adjusted by the dual rate function. For example, a good place to start there is around 70%, which is already set up on a Futaba. The bend on where it catches up, I like to set it up at 100%. In other words, it only catches up when you move the stick all the way. Some people have it start earlier, but that's, again, it's personal choice. These functions really, again, are not necessary, but it helps on making you a better pilot more easily.
David, are there any other neat tricks you can do with the programmable radios?
Yeah, there sure are. One is that you can put more than one airplane in a transmitter. For example, the 9-channel Futaba will hold, I believe, 6 airplanes. What that means is all the adjustments, some like we talked about, the expo, reversing, etc. After we got this all set up, it goes into memory, and I can do another airplane entirely different with all the adjustments and call upon that. So I can have one transmitter for more than one airplane. Something else you can do with that feature, so let's say on airplane A, I have the Extra 300, and I have some ideas. I want to try some changes. I can load airplane A into B by copy function. Make the adjustments. If I don't like it, I simply go back to A and continue on. If I like what I did to the airplane in B, load B into A, and now I have the airplane with the new adjustments. Nice feature. Some people have gone so far as have airplane A on their Extra, for example, for a windy day. On a calm day, they go into the B setup. Another thing is that there's endpoint adjustments. They call it
ATV.
ATV, right. Sometimes that's misused. I'd like to bring that up. For example, let's say your ailerons are too sensitive. What you don't want to do is dial it out through the ATV. The ATV is strictly for fine-tuning. In other words, get the airplane as close as you can mechanically by arms, on the servo, and on the elevator, and then fine-tune to get exactly the deflection you want on the ATV function.
David, what is the differences between FM and PCM?
Well, there are significant differences. One thing to note is that PCM is transmitted on FM. What it really comes down to is they glitch differently. If there's interference, they handle interference a little differently. An FM, if you get some interference, you'll notice it immediately. It'll start, surfaces will start to jitter. With a PCM, it's a computer-sent signal with a computer on the airplane looking at the data. When the data gets garbled or there's interference, the error count goes up. And when it goes up to a certain level, then the radio makes a decision whether to continue listening or to either go into hold or into a program failsafe, which you can program into PCM. Is there an advantage? There probably is a slight advantage to PCM. The bottom line is they glitch or handle interference differently.
But a good FM radio can be used for aerobatics just as well.
Absolutely, absolutely. One of the airplanes we're going to use today is the Carl Goldberg Models Ultimate 10-300. Very popular kit. We're using a YS-120, a Futaba radio, and it's an excellent aerobatic airplane, particularly for hot dog maneuvers, which we're going to show later on the tape. Another airplane we're going to use today is a Carl Goldberg Extra 300. Like the Ultimate, it's very similar scale aerobatic airplane. While I can't do all the hot dog maneuvers, it's very precise, excellent flying airplane. Again, we're going to be flying it with the YS-120 and the Futaba radio. This is the Conquest 7, the latest in a series of pattern competition planes that I designed. We're using a Futaba radio and a YS long-stroke engine. This airplane, while it's designed specifically for competition aerobatics and the 22 maneuvers, is not particularly well suited for hot dog flying, but very well suited for precision aerobatics. Okay, Don, now that we have the computer radio set up and the engines tuned in and the hardware all taken care of, the most important thing about aerobatic, or I should say precision aerobatic flying, is the precision part. Lines, symmetry, etc. And once you get that down pat, you have to learn how to do that in different wind conditions. This is really what precision flying is all about. Getting full control of the airplane under various conditions, putting it exactly where you want. Once you've mastered that, that makes the hot dog or hot dogging even easier, which we'll talk about in video number 3. Anyway, now that we're ready to go, let's go fly.
David, when you're first learning knife edge, is it helpful to always roll in the same direction?
Yeah, when you're learning any maneuver, you should work on the same direction. The roll should be the same way. If you prefer right to left, practice from right to left until you become proficient. Then you can work on the other direction. Our first maneuver here is a knife edge. The first 2 shots were a little low. When you're learning how to fly, you want to start a little higher. Roll to 90 degrees. Add enough rudder to keep the nose up. And roll out. This is a really good practice maneuver to become proficient with how to hold the nose up while you're in knife edge.
Very nice.
Try to visualize the maneuver in your mind before you go on. Now we're on to the slow roll. The first part's just like the knife edge, but now we're going to continue and go all the way around. Left rudder to hold the nose, little down elevator, little right rudder, and we finish. In slow motion, this gives us an opportunity to look at the inputs. Little left rudder here, down elevator goes in goes the right rudder, and we finish it. In real time, slow roll should take about 4 to 6 seconds.
Very smooth.
Okay, another variation of the slow roll. We stop at every 90 degrees. We call it a 4-point roll. First point, just like the knife edge that you learned first, like so. Little down elevator, little right rudder, and we finish. Just like the slow roll, the left rudder, little down elevator. The only difference is that we're stopping the ailerons at every 90 degrees.
There's a rhythm to the sticks, isn't there, David?
It's a timing maneuver.
Visualizing what you were going to do before you did it obviously would be of help.
You should have a pretty clear picture of what the maneuver looks like in your mind and what you have to do before you try it. That's what makes this tape so helpful.
Yeah.
8-point roll, again like the slow roll and the 4-point, except now we're stopping at every 45 degrees. And again, it should take about 4 to 6 seconds to complete the maneuver.
Is there control input for those extra clicks?
Just like the slow roll, the only difference is that we're stopping every 45 degrees. You notice that we have the rudder and the now little down elevator. Little right rudder goes in, more right rudder, and remove the right rudder in the last one. Here's an opportunity to learn a fine point of an 8-point roll. On the upright portions of the 45 degrees, point 1 and 7, add just a touch of up elevator. This helps reduce loss of heading during the maneuver. Well, that was fun. Let's take a break at this point to talk about practice, how much to practice, etc. Burning lots of fuel isn't always productive. I like to practice probably about 3, maybe 4 flights in an afternoon, no more. It's very difficult to maintain concentration beyond that. The other thing is try to set goals and short-term goals and long-term goals. Long-term meaning, at the end of this summer, I'd like to be able to be at this level of proficiency. Short-term meaning, today I'm going to perfect my 4-point rolls. I've been having some difficulty. Or today I will start to learn a new maneuver and learn it by the end of 2 weeks. Planning and setting goals really helps in improving your flying and building on your flying skills. Lots of fun. Let's go back flying.
Good.
Okay, now we're going to work on looping maneuvers. The outside loop takes a half a slow roll to enter, and we push a little down elevator to go around the top. Good time to throttle back. And we do the other half of the slow roll to finish. There you go. Let's try the same thing with the extra. To make the maneuver look like, or the loop look nice and round with the same speed, throttle management is pretty important. Okay, with the extra, now we give full power. Okay, we push. You'll notice that we have a little left rudder. Typically when you push for an outside maneuver, left rudder input is needed. We throttle back so we don't build up too much airspeed. And we exit, or do the other half of the slow roll. Right aileron and right rudder. There we go. Let's watch it in real time. Half a slow roll. Full power, push. A little left rudder to keep it straight. Throttle back to keep the airspeed the same, constant. And roll right, slowly, the right rudder. You can see where, if you've learned to do your slow rolls in one direction, how they become helpful.
Everything just builds on everything else.
Right.
It's really a good system, David.
And again, to remind you, almost all aerobatics is a combination of a loop and a roll. Here goes a half a loop with a half roll on top. And we push to a half outside loop with a half roll. The rolls are not slow rolls here. If we were to do a slow roll in the double Ilmerman, it would take too much airspace, so we tend to do a quicker roll on top and on the bottom. Another thing, these rolls should be done immediately after the loop portions. Remove the elevator and roll right away. A pointer to help you through this maneuver, if you've been rolling right, which is the direction I prefer to roll, typically in the double I you'll need a little right rudder like we have here. Now since we roll right, that's the correct rudder input to hold the nose up for that roll. So roll right, right rudder. Throttle back so we don't have too much extra speed.
Is there small rudder input on the downside of that, David?
That's something you have to observe. Again, we roll right to upright, and we had right rudder to hold the nose up. If you don't apply the rudder, the nose will drop, both the upper roll and the bottom roll.
That's something you definitely want to have together before you...
Right. But see, if you've learned how to do a slow roll, and you learn how to do outside loops, inside loops, this again is a building block.
If your purpose was in advancing so that you could do hot dog or more advanced maneuvers, things scary and close to the ground and all, being able to control the nose, obviously is something you have to have together.
Mm-hmm.
You want to practice that up high.
Well, you can see how these pattern maneuvers really can build proficiency on rudder and throttle. Okay, we're into the Cuban 8. Again, it's, I believe, 5/8 of a loop with a half roll. A couple of key points here. Those loops have to be the same size. The rolls have to intersect. Okay, now we're pulling. Keep those wings parallel to the ground, correct with the rudder. Now we roll. We like to roll halfway on the straight portion. Mentally, in your mind, if you remember where that spot was, then you fly to hit that intersect point.
Yep, that was at the same cloud.
Now let's watch this in slow motion. Okay, up we go. If you remember, generally when you pull for an inside loop like this one is here, you generally need a little right rudder. Now, of course, this will depend on wind, and if you started with the wing low, that's something else. But generally need a little right rudder. We throttle back. Halfway through the straight portion, we're going to roll. We again, throttle management is to keep the airspeed as constant as possible. Little right rudder. Again, we're doing an inside loop. Throttle back. Because you're coming down, you don't want to go too fast. Like your slow roll, I sometimes add a little top rudder on the downward roll to make it look a little more axial. Okay, we'll watch this again in real time. If you're being judged, they're going to look at two things. They're going to look at the size of those two loops, if they're the same size, and they're going to look, they love to watch that intersect point. Many times you see a judge put his hand up to remember where that space was. And it's good practice. You're getting some looping experience, and you're getting rolls thrown in at the same time, and in two different directions in one maneuver.
David, as long as it takes to complete this maneuver, and as much sky as you use up, if there was much of a crosswind, that really could play havoc with that maneuver, couldn't it?
Right. Any maneuver that has a lot of hang time or a lot of exposure time, if there is wind pushing you in or out, it's going to have quite an effect on your position. The easiest thing to do when you're learning how to compensate for a crosswind is when you enter that maneuver, if the wind, for example, is pushing you in, keep the nose out. If you have the nose out correctly, or the correct amount, before you enter, and maintain that position of the nose throughout the maneuver, you'll have it knocked. Here we go into a snap roll.
Got it. Beautiful.
Basically, a snap roll is a high-speed horizontal spin with full power. Full elevator, full rudder, full aileron. Okay, here we go. You'll notice that I remove rudder a little bit before I remove the aileron and elevator input. This is to reduce the heading loss. Here we go. Nicely done. The Ultimate does a fine snap roll. Okay, here is an avalanche. That is a regular inside loop with a snap roll on top. Okay, we're going to watch the extra do it. Nice round loop. Just before you reach the top, you snap. That's so you're snapping through the center portion of the center top of the loop. I like to snap with full power. I think it snaps a little bit more authority. Another thing I like to do is to take the elevator out of the loop just before I snap. This helps prevent chopping off the top of the loop. Okay, here we go at full power. See the up elevator we have to fly through the loop? I'm reducing the elevator. We'll touch it down, snap, and release. A cleanly done avalanche is really a pretty maneuver to watch.
It's gorgeous.
Okay, you notice how we throttle back, try to keep the airspeed as constant as possible. Another reason I like to keep full power in the avalanche is through the snapping part is so I don't lose too much speed at the top of the loop. Okay, remember just before, a little bit of down real quickly and snap. Down we go.
I've long thought it unfortunate that that video tends not to be able to show the majesty of these maneuvers. If people were out there and could see you do these things are monstrously tall. We try to show clouds when we can to see how big they are, but they're unbelievably tall and majestic.
A lot of power helps here. I do not use a snap button. A lot of people do. I prefer to fly these snaps by hand. Another variation of the loop is a square loop. Not quite as simple as it sounds. There's a lot of places it can go wrong because of the change of airspeed. Couple of points to work on. Try to keep the radiuses the same on all four. It's difficult to do because the top corners are done at a much lower airspeed. So a common error is getting 4 different radiuses. The biggest radius typically is the last one, this one here. And another mistake is not having all 4 sides the same length. It's a good maneuver to work on your proficiency. Notice we have a little right rudder as we crossed that top corner. Remember when I tell you, whenever you pull, you typically need a little right rudder? See a little right rudder as we're pulling around here? Very subtle.
David, does it matter whether these maneuvers are entered upwind or downwind?
Virtually all looping maneuvers should be done upwind, and all rolling maneuvers should be downwind. Okay, here we go in real time. Again, throttle back to keep the airspeed constant. While this is an F3A maneuver, a competition maneuver, even for hot dogging, if you bring that low and close, it's an impressive maneuver to watch. What a beautiful day for flying. Remember, practice does make perfect, yet don't over-practice. What we've done in this tape at the end here, you'll see that we've taken the maneuvers that we learned today and strung them together, which is actually part of the FAI schedule for a competition. Now that we got your proficiency up to a very high level, you'll be ready for our next tape, which is hot dog flying. Look forward to seeing you there.
Can't wait. Thank you, David.
Take care. Okay, here we've tied these maneuvers together. The first maneuver is a half reverse cubanate, like the cubanate we did before, but we pull and do the half roll first. Now we're going to the the 5/8 of a loop. Pull the way up, half roll. This half roll should intersect. And we complete. Now we go into a stall turn with half rolls up and down. Half roll should be in the middle. Nicely done.
Hold the rudder in so the tail doesn't wag?
Yeah. Tape number 1. Now we go into a slow roll. Now we go into a half square with a half roll. That's the top part of the square. Throttle way back, pushing those down 45 degrees. Snap roll.
All things that we've learned.
All the things that we've learned. Everything you ever wanted to know is in those maneuvers.
That's great.